Hello everyone. This video will be the tutorial for the SPSS Survival Manual homework for Chapter 6 in Pallant, and we're going to continue practicing with how to run descriptive statistics so that we can describe our samples. Now this time, in comparison to the work we did with Chapter 5, now we're really wanting to be able to describe our participants in terms of demographic variables, and we want to check some of our assumptions and examine descriptively our variables of interest, for example, a dependent variable. So that's why your homework is set up in the way it is. The first three items on the homework are asking you to learn how to run descriptive data on demographics. So we have the age, sex, and smoker variables. The first of those is a quantitative variable. So age, is reported in years, and we want to know what's the mean age of the sample, what is the range of the ages, so the high and the low, so that we can describe that to our audience. In questions 2 and 3, we're dealing with qualitative variables. They're nominal in nature, and we want just to report that in terms of frequencies and percentages. The final question on the homework is one of the dependent variables in this study, total negative affect, and what you're being asked to do is to assess something called normality. And when we get down to the point where I'm giving you a tutorial on how to do that, following the instructions in your textbook, I'll give you a little primer on why we do that. All right, so I've already got my survey.save file open, and I'm going to start with number 1, where we want to be able to describe the sample in terms of the variable age. So I go to Analyze, Descriptive Statistics, and since this is a quantitative variable, the easiest way that I've found to generate this information, because you can do it either through frequencies or through descriptives. I just prefer descriptives because I don't need a frequency table of age, at least not most of the time. So I select age as my variable and move it over to the variables box. I want to click on options and make sure that mean, standard deviation, minimum, and maximum are selected, and then I'm going to hit continue. Now, before I do that though, there are other things that you can check for using the descriptives options. We're not doing those with this homework, however. Okay, so what comes out is a very simple output. You have the number of cases, 439. The minimum age reported was 18. The maximum age reported was 82. The mean for the sample was 37.4. The standard deviation, 13.2. Now for the next two items on your homework, you have two qualitative variables. So I'm going to handle them both at the same time. So I go to Analyze. And this time, instead of descriptives, I'm going to choose frequencies. I'm going to select the sex variable, and I'm going to select the do you smoke variable. And here, in my instructions to you, my step-by-step, I say go to Analyze, Descriptive Statistics, Frequencies, move the variable over, and then go ahead and click OK. Just for future reference, there are some other things that you can ask for. You can ask for statistics, you can ask for charts, and a variety of formatting options if you want to. Most of the time, they are not necessary. Make sure that the Display Frequencies table box remains checked. That's by default. It should be checked when you open this dialog box. So we've got both of our variables that we want to look at checked, and the output will give you both. So this first box, since I've selected two variables and asked it to do the analysis at the same time, this may look a little different than what I gave you in the key when you go in and do your homework and input your answers. But you see you have for the variable sex, everybody answered the question. There's no missing cases. With the do you smoke question, however, you have 3 missing cases, meaning there were 3 people who did not respond to the question. The second table here is for the variable sex. And remember that for this research project, there were only 2 options, male or female. You've got a total number, 439. You have 254 females, 185 males. 42% were approximately were male, 57.9% female. The other 2 columns, we rarely report those when we're describing data in research reports. For the smoke variable, you have, again, you have 2 choices kind of question, either yes or no. You either are a smoker or you're not. The frequencies, 85 said yes, 351 said no, for a total of 436. There were 3 people in the sample who did not answer the question. And then you're given the percentages. And you can see the impact of the missing data. You have 0.7% missing data, and that's well within a tolerable range of people who didn't respond to the question. For number 4, we're doing something different. This time we're looking at one of the dependent variables in this piece of research, in this case total negative affect scale scores. Now remember what a scale score is. You have a set of items, so the negative affect scale has a set of items, and participants respond to every item making up the scale, and then a total score is generated by adding up people's responses to each of the items after doing any applicable recoding, such that high scores mean one thing and low scores mean another. So we want to look at how normal the distribution is. And by normal, you've probably heard the term a bell curve. Normally distributed data means that you have the mean and the mode and the median are equal. And then on either side of that mean, mode, and median, you have this pretty bell-shaped curve with fewer and fewer and fewer participants having scores that go into the extreme low end, and fewer and fewer participants with scores at the extreme high end of the possible scores on a given variable. Now, why do we want to find out if our scores on total negative affect are normally distributed? Well, primarily because most of the statistics that we might want to use later, such as correlations and t-tests and ANOVAs and on, will make an assumption that the data we're looking at is normally distributed. And those statistics have varying levels of tolerance for violating that normality assumption. Now, I'll be honest, most of the time researchers try to give a lot of latitude to this non-normality. Hardcore statisticians, even moderately hardcore statisticians, kind of go, ugh, when we all do that. So there's the rules, and then there's reality of practice. But I want you to know how to do it nevertheless. So the steps are outlined for you on page 60 in Pallant, and you'll notice me running my finger. You might be able to hear it looking at those instructions to take you step by step so that you can look at the descriptive statistics, the mean, mode, median, minimum, maximum, and so on, but then also to look for outliers, so potential outliers who might have really extreme scores that you need to make decisions about whether to keep them, whether to let them go. For example, if you have a very tiny number of really unusually high or unusually low scores that are messing with your mean. So if I have some really low scores that are way out of range of how everyone else was responding, they're going to drag the mean in the direction of their scores. If they are truly outliers and don't really fit with the sample for whatever reason, then you may want to make a decision to remove them from the sample. that's a complicated conversation and one we'll expand on at a later time. So how we do this, we go to Analyze, Descriptive Statistics, which is where we've been living lately, but this time we're going to select Explore. We want to go down and find the variable we're interested in, and the homework, I ask you to select total negative affect, and then you're going to put that in the dependent list box. In the label cases box, you're going to go all the way back to the top again, and you're going to select ID. Then in the display section, you want to make sure that the button both is clicked. Then you go up to statistics, you select statistics, and you want to click on both descriptives. That should be the default, so it should already be selected, but we also want to know about outliers. So we're going to select that, and then we're going to click continue. Under plots, we're going to click on that and open the box. We want, under descriptive, we want to see the histogram because we want to look at the shape of the distribution, and a histogram is the easiest way to do that so that you get a visual. Now we could get a stem and leaf as well. I think I'll go ahead and select that so you can see both. Then we also want to check normality plots with tests, because we want a test statistic to tell us whether or not our distribution of scores on this particular variable have violated assumptions of normality. Then we click continue. Under the options button, Pallant instructs you to, in the missing values section, to click on exclude cases pairwise. And then you click continue. And then you click OK. All right. Now, I would encourage you to kind of very carefully, as you look at the tables, this is probably the first time in your very early exploration of SPSS that you're going to deal with output that is more complicated, where you have multiple tables to look at and explore, and then you have plots, stem and leaves, histograms to look at, and so on. Some of it you will want to pay attention to, some of it you will not. So we need to look at each one at a time, just like Pallant does in the text. The first table that you run into gives you how many participants could, for how many participants could we calculate a total negative affect score. So remember, participants are responding to several items that make up the negative affect scale. And in order to generate a total score, they have to have answered all the items. They have to have had an answer for each item making up the scale. So we've got valid cases for whom we have total scores was 435. That makes up 99% of the sample. There were 4 cases making up 0.9% for whom we could not calculate total scores. So there were 4 individuals who missed at least one item making up that scale. The second table here gives you your descriptive statistics, your mean, your median, your variance, your standard deviation, the minimum score, the maximum score, the range between those two, and so on. It also gives you a skewness score and a kurtosis score. This next table, extreme values, is what's looking for outliers, and there are a variety of ways of interpreting this kind of information. What we want to look for is how many, but more importantly, we want to look for where those values are and what kind of impact might these individual participants have on the way our distribution is laid out. So what this gives you on the extreme values list, it gives you by ID number, and this is why we had to use that as one of the variables that we checked in a box when we were setting this up. So on the high end of scores, we have ID numbers 24, 415, 144, and so on. And then it gives the value of their score. And then on the low end, you have these ID numbers. Now notice this is a partial list of cases at the upper and the lower end for you. But it gives you kind of a way of visualizing what kind of outlier values you might be looking at. The next thing that you look at is the statistical tests of normality. And as Pallant notes, what you want here is a non-significant result. So, because if you have a non-significant Kolmogorov-Smirnov test finding, that means that you do not have a distribution that violates normality. So it's not significantly different from normal. Unfortunately, we have a significant Kolmogorov-Smirnov test result. That means that our distribution of scores does deviate significantly from normal. Now, it's always helpful to have a visual way of representing that, and that's what a histogram does for you. You notice that the tail here of your distribution is drugged toward the high scores. So when we look at this mean of 19.4, that would be around here. But you also notice, what happens, why is the high peak over here? Well, part of why the mean is being drugged so far away from the highest peaks in the distribution is because of this chunk of scores that are up here. You have this tail pulling that mean a little bit high instead of having low scores. So when we go back to this table here, looking at the lows and highs and the fact that it's only a partial list, you have a chunk of people who are down here between 10 and 15, but you don't have that nice easy slope away from that mean value down to the low end. Over here, you have too easy a slope heading up to the high end. So it's a non-normal distribution. If this were normal, you would have a nice flowing bell-shaped curve with the mean, mode, and median in the middle of it, and you could fold it in half and the two sides would be symmetrical. That's definitely not what we have here. Now these other plots that you have, the stem and leaf kind of lays out things in number terms for you. You can see the same shape. So when I do this, I only check the histogram. It's visually easier to apprehend and easier to describe. These other plots, this last one helps you to look at some of the potential outliers. So you could make a decision. I'm not saying it's warranted in the case of this particular data set, but if you had good theoretical and statistical reasons for doing so, you could say maybe these values right up here, these ID numbers, maybe they are misrepresenting the sample. Maybe there's something unique about that group of participants that sets them apart. Again, I'm not saying that that's true for this study, because certainly Pallant in her description of the use of this data set has not made a decision to eliminate any participants, instead choosing to keep them. The mean score and the bulk of scores are in the box. The outliers that are affecting the mean are up here. And it's always a difficult set of decisions for researchers to decide, should I remove participants, should I keep them in? In my experience, trying to make decisions for myself about outliers, I tend to want to remove them only if I have an exceptionally good reason to do so. So let's say I have a study that relies on people, and I'm going to come up with an example off the top of my head that's probably more likely to play out in Dr. Knapp's lab. Let's say I want to look at people who I assume have normal blood pressure levels at baseline. And I've tried to select very carefully only participants with normal healthy values for blood pressure. And I discover at a later point in time that I have a couple of participants who actually had really high blood pressure ratings or moderately high blood pressure ratings after the data was collected. And then I also find that their heart rates were higher and their heart rate variabilities were problematic. I could say after the fact, those are outliers. They should have been screened out in the first place, but they were not. So in essence, they were included in the sample by error, and then you can justify removing them from the sample. In questionnaire research that I've done, I have typically not removed people unless I had a reason to assume that they were manipulating their responses in order to represent themselves falsely. So that does it for our presentation, or my presentation of the tutorial for homework chapter 6.